Hey, welcome back to another episode of the Shakedown, where we bring in vibration education experts from our company, the Cleveland Vibrator Company, and we discuss everything that has to deal with industrial vibration. So today we have Derek Stake. He's our Director of Ops here at Cleveland Vibrator, and he is here to talk about his latest blog that he has written for our blog content. So welcome, Derek.
Thanks for having me.
No
Glad to be here.
Can you tell us a little bit about yourself?
So I say that I am kind of an enigma, where I'm kind of a jock but a nerd at the same time, and it's a weird combo.
It is so accurate, though. Yes. And how long have you been with CVC?
3 years now.
Okay. Is it been that long?
I know. It's
Oh
flying
my
by.
gosh.
Absolutely flying by.
Yeah, Derek came on board right before our big building move, and a lot of great things have been happening under his leadership out on the plant floor. So it's been a fun ride.
It's been the team's effort, and it's been so much fun.
Oh, absolutely. 100% agree. And hey, Derek, you came to us and you were really excited about figuring out the why of our products. We know that they work well out in the field, but why do they work so well? And you decided that you were going to address that in your blog series from a technical engineering perspective.
Right.
So your latest blog that you wrote is titled How to Stop Fatigue Failure During Vibrator Installation. And you mentioned this topic has been referenced in other blogs, but you wanted to provide more insight from your engineering perspective. Why did you decide to cover this topic in particular?
Well, a lot of the things that we do are based on best practices from years of experience. So we have, we've been in business for almost 100 years now. We have just a lot of really good, this is how you do it. But we don't really explain the science behind why we do what we do. So I wanted to go in depth into the actual science of what makes this how we do it.
All right, and what are some common mistakes you see our customers make when it comes to choosing the vibrator, the first step in the vibrator installation process?
Yeah, so a lot of times they're trying to compare vibrators from different manufacturers, and they're just looking at the force, and they're not really trying to understand the type of object or the thickness of the object that they're trying to vibrate. So they don't really understand that they're trying to actually move a wall to create the vibration. So they either choose something that's too big and they break their wall, or they choose something too small and they don't actually move the object that they're trying to vibrate. Okay. So they're not really using the methodology that we use, which is we have a sizing guide that is there just to
shameless plug,
just to help people know that how to deflect the wall of the hopper, and that's, I think, the number one mistake.
All right, and what about mistakes regarding installation? What are some of the common mistakes customers make while installing the product on their mediums?
Yeah, the number one mistake, and that's why I wrote the blog, is the welding. A lot of times everyone they think more weld is better. You want to weld all the way around the corners, then that's going to be stronger. Well, that's not the case, because when you're actually trying to deflect a hopper wall, you need to have some movement there. Right. So you want just enough weld to keep the mounting channel on the wall, but not too much to constrain the movement, because what you want is that wall to deflect to make the grain or powder or something inside the hopper actually move and then shake down into the next process.
Right. And is there any installations that you've seen, field photos that we've been supplied, that stick with you?
Yeah. Yeah. So there was a stainless steel hopper that they put a stainless steel mount on, but this was after they had already tried to weld on a mild steel one. What stuck out to me is that when they cut off the mild steel one and welded a new one on, they just welded the weld right on top of the old weld. So it was this big globby welds, and they were all cracked, and they were cracking out, and that stuck with me because they didn't clean up the weld as well. So you want to make sure that the surface that you're actually welding to is nice and prepped. It doesn't have extra stuff on it. It's nice, smooth, and then you can actually get a good penetration with your weld on that surface.
Okay, excellent. So we're going to delve into some more blog-specific questions, things that you touched on in your blog that we had published to Solutions in Motion. And one of the things that I'd like to talk about today is, you already touched on it briefly, with vibration, how does it increase material flow when applied to the hopper, and what happens to the material?
Yeah, so there's a lot of variables with your material that's actually helps it flow and keeps it from flowing. There's moisture, there's temperature, there's the actual size of the granules, and I like to think of it as like a Tetris game, and we're trying to blow up that Tetris mountain. So all these little bitty particles, they can kind of fit together and they can settle and lock in place, or they're sticky. So they'll actually hold on to each other. And what we want to do is we want to deliver enough energy through a blow with a vibrator,
Right.
Either an SI vibrator or a VMS or a VMSAC vibrator, to actually break those components up so they can start sliding again in your hopper.
Okay.
So that's what we're focusing on. We ask a lot of questions. Our sales team will ask a lot of questions on what's in the hopper, what type of temperature, what's the environment, and people are like, well, no, I just want to shake the hopper. And I'm like, no, all of this matters on how we're going to actually apply force and frequency to make your stuff move.
Right, and for those who don't know, he's dropping some CVC lingo up in here. SI vibrator is a single impact vibrator. It's an air piston vibrator that when it's applied to the side of a hopper, it acts like a sledgehammer blow.
Yep.
You set it up to a timer and it delivers just an impact one every 3, 5, 10 seconds, 1 minute, up to you and what works best for your material. And he also touched on the VMS, VMSAC. Those are both air piston vibrators. The VMS is an impact piston vibrator. It delivers a lot more force with metal to metal impact of the piston. And the VMSAC is a quieter option. It's still going to deliver the great force of an air piston vibrator, just at a lower noise level.
Right.
So, just in case those who are watching go, what the heck is a SI and a VMS? What is this man talking about? That's for clarification.
Yeah, and the VMS and the VMSACs also are more continuous duty, where you just turn it on and it's going to wrap against the side multiple times at a set RPM based on the air pressure that you actually apply to the vibrator.
Right, and when he was talking about variables, this is another topic for another day, but simply put, some continuous vibration is going to be better for better flowing material, free flowing material, while a single impact may be better for material that has high moisture content, tends to be a little bit more sticky, and a hammer blow is going to be more effective.
We get more bridging, caking up of the material.
Right, so those are just some of the factors that our team takes into consideration when we tell you, maybe this model is better for your particular application, but it boils down to what works best for your application, because there's no cookie cutter way to do this.
Right. We're customizing every solution for every customer.
Right, and from an engineering perspective, all of these factors, why are they important to an engineer?
Well, we want to make sure that we're providing a solution that's robust and efficient. So we're actually taking into account when we say, hey, it can deflect a wall that's a 3/16 stick or 3/8 stick, we're taking into account this is going to see some cyclical loading, and we want to understand that there's going to be fatigue stress, there's going to be stress risers, and we want to make sure that we're providing a solution that doesn't immediately cause failure. Because that hopper that they're putting in, that hopper is thousands of dollars. It's an asset. You don't want to see it broken. You don't want, and that's downtime, or loss of production, or loss of material when that stuff falls out of the side of the hopper because it's broken.
Which essentially is a loss of money.
Exactly. So we want to make sure we're providing the right solution. So we think of all these things every time we provide a solution, and we're thinking of it from a stress strain point of view, where we're trying to say, don't allow the material to actually fail.
Right. You had just talked a little bit about fatigue failure, and I know my fatigue failure comes from not having enough coffee in the morning because my 2 kids drive me nuts by noon. What's your fatigue failure?
So, in an engineering perspective, I think more of like stress. For personal, I think it's beating my kids as well. Right? So, but not coffee related. I don't drink coffee. I know I'm weird. I drink just water. But like at the end of the day, you worked a long day, and then you go home and you try to play with your kids, and you're outside playing for like 2-3 hours.
And it's exhausting.
Oh, it's absolutely. They have energy for days, and
where does it come from?
Nuclear power plants. They're all mini nuclear power plants.
You're not wrong. Okay, so that's your primary cause for fatigue failure.
I'm failing at the end of the day. For sure.
Well, from a technical standpoint, would you like to touch on that more in terms of industrial vibration?
Sure. Yeah. So your hopper wall is going to see fatigue. It's going to see a cyclical loading every time, even if it's a SI or it's a slower frequency or a VMS or VMSAC. It's seeing a cyclical loading. And cyclical loading leads to fatigue failure. Over a length of time, a force being applied in a fashion like that leads to fatigue failure. So what we're trying to do is apply the right amount of force at the right frequency for your hopper so that you don't see that fatigue failure. Or if you do, it's years down the road, 10, 15, 20 years down the road, where you're looking at buying a new hopper or upgrading your hopper anyways.
Right.
And then there's a lot of other factors too that we are trying to address. So the reason why fatigue failure is critical is that it happens at stress risers. And when there's a stress riser, the fatigue failure is going to set in that location. When you weld the edges, when you weld the corners of your bracket, you're creating a stress riser by not allowing the wall to actually flex. So that's where the cyclical loading will actually happen and occur much sooner. instead of that 10, 15 years, it could occur almost instantaneous because you've constrained the wall. You could turn it on and a minute later you've got a crack. So that's why we're trying to make sure that everyone is aware, don't weld those brackets all the way around the corners, because you're creating a stress riser that leads to a cyclical failure, that leads to stress risers and all these other things.
Yeah. So just the long and the short of it, don't weld the dang corners.
Yeah, right. Don't weld the corners. Choose the right vibrator.
Yeah, these are all variables that it seems so simplistic in nature, but when you actually look at the grand scheme, there are a lot of factors, variables that play into properly running a vibrator so that its life out in the field will be what it should be.
Correct.
So
yeah, and then sometimes there's just no way around it. You got too thin of a wall. We actually have an option where you can create a stiffener plate, and the stiffener plate you can have welded to the hopper wall to thicken the wall to give it more strength. Then you mount the vibrator mounting channel, then the vibrator, and that helps also reduce the cyclical loading and the stress risers and the failures that actually occur.
but sized properly, you're still going to get the result you want, the material moving out, right?
Yep.
So don't ever think that adding the extra channel is going to inhibit the movement of the material inside.
Nope.
It's just going to help you keep your equipment longer and better.
Keep it safe.
Yes. And by the way, just as another plug here, never take a hammer to your hopper. Hammer rash is ugly and really expensive to fix. Vibrators are so much better.
Well, and it's not very safe either, right?
It's not.
You have a gentleman that's trying to hit in a very
Or it could
low
be a
pressure
lady. I'm throwing it out there.
Definitely, for sure. You have an employee.
There we go.
Who is now crouching, underneath your hopper or getting into a location that's not safe for them, and they're trying to hit the side of a wall. They can put their backs in compromised positions. They can hurt their arms. There's a lot that could happen, and we want to protect those employees. They're an asset just as much as the hopper.
Safety is the absolute most important part of this.
Agreed.
Well, Derek, thank you so much for joining us
Thanks for having
today.
me.
This has been super fun. And folks, we have so much content available from our team, from engineering, sales, and everybody in between. The team here is always willing to help in any way possible. And part of their help is, giving us pestering marketing folks content when we ask for it. And he had also referenced the sizing guide. This is our industrial vibrator selection guide. And this is a step-by-step guide from proper force and frequency selection based on dimensions of your hopper, your bin. We walk you through what's going to give you your best option in terms of your application and your vibrator that you need. But moreover, what's even better, we talked all about these welds. Well, we have really gorgeous, beautiful pictures that show you what we were talking about today. This resource is super easy to find. You can find it on our website, clevelandvibrator.com. We've also shared it in our blog site a bunch of times across our social media platforms. All you have to do is Google Cleveland Vibrator Industrial Vibrator Selection Guide, and it'll pop right up to this PDF. It's free to download, complete resource at your fingertips anytime you need it. And as always, our team is always standing by to help. Sales at clevelandvibrator.com. Visit our website, interact with us on social media, #Vibration Education.
That's right.
Yeah, super fun. We love what we do around here, so share in the fun with us.
Yes, yeah.
All right. Thank you so much, Derek.
Thank you, appreciate it.
All right, till next time, movers and shakers.